Okay, for this problem, we are given a sequence, and the question is to find a recursive definition, find a sequence that is recursively defined that produces these terms. Okay, well, let's just start doing this. There's no good way to do this in general other than you just stare at it for a while and try to find a pattern. One thing that may or may not work, depending on the problem, is to just simply look at the difference between terms. Like, to go from 5 to 9, we need to add 4. Then from 9 to 18, we have to add 9. From 18 to 34, we have to add 16. From 34 to 59, we have to add 25. And then you can see that the things that we're adding are perfect squares. And so that is a tip-off that that might be the way to do a recursive definition. So let's recursively define our sequence. So if n equals 1, then we'll start on 5. Then I have to come up with something if n is greater than or equal to 2 for the second term, the third term, the fourth term, and so on. Well, the previous term is going to be the next term is going to be equal to the previous term plus something. Now, what's the something going to be? For the second term, I add 2 squared. For the third term, I add 3 squared. For the fourth term, I add 4 squared. And so it looks like for the nth term, I ought to add n squared. And so that is one way of recursively defining the sequence. And I'm presuming that the sequence starts on n equals 1. Okay, now that's correct. For the sake of completeness, let me do this again. But this time, let's suppose that the sequence starts on n equals 0. So that's the 0 term, that's the 1 term, that's the 2 term, that's the 3 term, and so on. Now it's going to look an awful lot like we have here on the left. It'll be the previous term plus something, as long as n is now greater than or equal to 1. Now, if that's the 1 term, I'm adding 2 squared. If it's the 2 term, I'm adding 3 squared. If it's the 3 term, I'm adding 4 squared. And so the pattern would be adding n plus 1 squared for terms n greater than or equal to 1. So both of these sequences produce the list on the top. The difference is that for this list, n equals 1 is the first term, and for this sequence, the initial term is n equals 0. Either sequence works. Certainly the one on the left is the most obvious. But both of these recursively defined sequences produce these initial terms.